Are you ready to get your head in the clouds without having to look up from your run, your commute, or your cutting board?
Then you're in the right place. Welcome to Cloud Concepts on the Run, where we take tech offline and keep you learning on the go.
Yeah.
I'm Tim, your friendly neighborhood AWS solutions architect.
And I'm Andy. I'm a tech nerd with a background in, consulting and mobile apps.
Okay.
And I'll be your co-host asking all the questions I know you're curious about.
Right.
Now, Tim, I think we need to confess something right at the start.
You're right. Let's just say it. We have AI superpowers. Your hosts for this podcast are, in fact, AI.
But wait, before you think this is just some robot reading a textbook, here's the most important part. Every single episode is inspired and outlined by brilliant humans with years of real, hands-on cloud experience.
Exactly. Think of it as the best of both worlds.
Right.
Human expertise working together with machines to make, great educational content.
Wow.
And whether you're studying for an AWS exam or are just starting your cloud journey, we've designed this for you.
We're so excited to have you learning with us on the go.
Yeah.
But we'll always be the first to encourage you to roll up your sleeves and get that hands-on practice in too.
Enthusiastic. Ready to dive in? Let's get started.
Welcome back to Cloud Concepts on the Run. I'm Tim.
And I'm Andy. Okay, Tim, today's the day. We're going to talk about something that gets a lot of people excited and maybe a little nervous. Getting AWS certified.
It's a fantastic goal to have. With just a few weeks of focused work, you can earn a credential that really does get you noticed by recruiters and hiring managers.
Yeah.
It proves you've put in the effort to learn the fundamentals.
But, and we're going to say this a lot because it is so important,
Right.
It's not just about the certification, right?
We cannot stress this enough.
Okay.
The certificate opens the door, but what gets you through it and keeps you in the room is hands-on experience. You have to get your hands dirty, so to speak.
And I think people hear that and think, but my current job isn't in tech. How can I get experience?
Yeah, exactly.
And this, to me, is the magic of the cloud.
Exactly. That's what is so great about AWS. They have something called the free tier. It gives you a certain amount of access to their most essential services for free, usually for your first 12 months.
Okay.
It's your own personal digital sandbox to build, break, and fix things without spending a dime.
It's your lab, your workshop. It's incredible. So if someone is opening up that free tier account for the first time, where do we even begin? What's the first concept they need to grasp?
We start with the literal ground floor, the AWS global infrastructure. First up, what is an AWS region? Simply put, it's a specific geographical area on the map.
Okay.
For example, US East 1 is in Northern Virginia, and EU West 1 is in Ireland. These are physical locations.
Okay, so a region is a place. And I assume these places are filled with massive buildings, stuffed with computers, what we'd call data centers?
You got it. But here's the crucial next step in the hierarchy. Inside each region, AWS has multiple isolated locations called availability zones, or AZs for short.
AZs, right.
Think of an AZ as a cluster of one or more of those data centers. Each region has at least two, but usually three or more AZs.
Chris, why have the separation? If they're all in the same region, why not just build one gigantic data center?
It's all about resilience and fault tolerance. The AZs in a region are close enough to have super fast, low latency network connections between them.
Okay.
But they are physically far enough apart that a single disaster, like a flood, a fire, or a major power outage, won't take out the entire region.
Ah, I see. So if my application is running in one AZ and that AZ goes offline, it can fail over and start running in another AZ in the same region without my users even noticing.
That is the core principle of building a highly available application. And this global footprint is what lets you go global in minutes. With a few clicks, you can deploy your application in a region in Europe, another in Asia, and another in South America, serving customers all over the world from infrastructure close to them.
Wow. Which brings up the next question I always have. How is this even affordable for a regular person or a small company? I mean, it sounds astronomically expensive.
It would be if you tried to do it yourself. But this is where the most important business concept of the cloud comes in. Economy of scale.
Like buying in bulk at a warehouse store?
Precisely. AWS is buying millions of servers. They're building their own fiber optic networks under the ocean. Their scale of operation is so massive that the cost for a single server or a single gigabyte of storage is incredibly low for them.
Right.
And they pass those savings on to you.
So instead of me spending millions on a data center, I'm essentially renting a tiny secure slice of their massive global data center.
And you only pay for what you use when you use it. That's the utility model. And this principle is what allows a two-person startup in a garage to use the exact same powerful, secure, and reliable technology as a global giant like Netflix or Disney. It completely levels the playing field.
That is genuinely powerful. We've gone from getting a certification to deploying a global application, all based on these foundational concepts. So what's next on our journey?
Now that we understand the physical infrastructure, the next logical step is to secure it. In our next episode, we're going to dive into one of the most essential and powerful services in all of AWS, IAM.
Identity and access management. Oof, I've heard that can be a huge, intimidating topic.
It can feel like a deep pool, but you only need to know the basics to be pretty darn powerful, and more importantly, to keep your account safe.
Okay.
And we'll break it all down for you.
I can't wait. It sounded like the digital keys to the kingdom.
You could say that, and we'll show you how to be a responsible key holder. For now, here's a question we'd like you to think about.
Ooh.
If you had access to a global supercomputer with a free starter budget, what one problem, big or small, would you try to solve first?
Welcome back to Cloud Concepts on the Run. I'm Tim.
And I'm Andy. Okay, so Tim, at the end of our last episode, you called AWS IAM the digital keys to the kingdom. And I've been thinking about that. It sounds, both incredibly powerful and a little bit scary.
It's both, which is why it's probably the most critical service to understand, like right from day one.
Right.
At its core, IAM is really the service that answers a super simple question. Who can do what?
So the who would be a person like me.
Yep.
And the what would be an action, like starting a server or reading a file.
Exactly. It controls who is authenticated, so who can prove they are who they say they are.
Okay.
And what they are authorized to do. And that leads us to the single most important security concept you need to know, the principle of least privilege.
That sounds like something you'd hear in a spy movie.
Yeah.
So what does it mean in practice?
It's a little less dramatic, but far more important. It just means you grant a user, or even a piece of software, only the absolute minimum permissions it needs to do its job, nothing more.
Okay. Let me try to put that in real terms.
Go for it.
So if my job is to write blog posts and upload them, I should have permission to add files to the blog folder, but I absolutely should not have permission to, say, delete the company's entire customer database.
You have hit the nail on the head, and that distinction is so crucial.
Wow.
It's the foundation of what AWS calls the shared responsibility model.
Oh, I've heard of this. This is the idea that AWS handles all the physical security, like the guards, the concrete, the global network,
Right.
the security of the cloud.
Correct. But you, the customer, you're responsible for security in the cloud.
Okay.
And that means managing your data, your applications, and using IAM to control who has access to what. It's your side of the deal.
And I can see how that could go horribly wrong. Can you give us a real-world example of what happens when least privilege is just ignored?
It's a classic and all too common scenario. So Imagine a fast-growing startup. They give a junior developer full administrator access because it's just easier, right? One night, the developer's cleaning up old resources, runs a script to delete some test servers, but they're tired and they make a small typo in the command.
Oh, I think I know where this is going. Don't tell me.
Yep. Because their account had unlimited power,
Oh, no.
that small typo didn't just target the test servers, it targeted and deleted the main production database. The entire application, the entire business goes offline instantly.
Wow. And that wasn't some, malicious hacker from across the world.
No,
It was just a simple, internal accident that was made catastrophic because of one bad decision to grant way too much power.
precisely. And it's why even senior administrators should follow this best practice. Use a regular, non-privileged account for your day-to-day stuff like checking logs or sending emails. Only log in with that separate elevated privilege account when you specifically need to perform an admin task. It's a simple but really powerful guardrail.
It really drives home the point that in today's world, especially in IT, security has to be part of every single decision.
Yeah,
It's not just for the security team anymore. It's everyone's responsibility.
it is. A proper understanding of IAM is your first and best line of defense to protect your company's data and reputation from external threats
Right.
and those simple, honest internal mistakes.
So we've established the what and the why, and in our next episode, we'll get into the how. We'll break down the building blocks of IAM, things like users, groups, roles, and policies.
Now, here's a question we'd like you to think about until next time.
Ooh.
If you were designing the keycard access for your own company, or even just your home, what is one permission you currently have that, if you're being honest, you probably don't need for your everyday tasks?
Welcome back to Cloud Concepts on the Run. I'm Tim.
And I'm Mandy. So, Tim, in our last episode, we established why IAM is so critical.
Right.
We talked about security, least privilege, the big ideas. Today, I think we need to dive into the how. What are the actual pieces we're working with?
I agree. It's time to look under the hood. And to do that properly, we first need a basic vocabulary for two of the most foundational AWS services, EC2 and S3.
Okay.
We'll be using them in our examples.
Okay, a quick primer. Let's start with EC2.
EC2, or Elastic Compute Cloud, is essentially a virtual server in the cloud.
Right.
Think of it as renting the engine or the brain for your application, the place where your code actually runs.
Got it. Virtual computer. So what's S3?
S3, or Simple Storage Service, is a massive, highly durable object storage service. It's the cloud's filing cabinet or warehouse. It's where you put your files, images for your website, video backups, documents, you name it.
Perfect. Engine and warehouse. Now that we know what rooms are in the building, let's talk about the keys. What are the building blocks of IAM?
It breaks down into 4 core components: users, groups, roles, and policies.
Okay.
A user is an identity. That could be a person, like you or me, or an application that needs to interact with AWS.
Simple enough. And a group is, I assume, just a collection of those users?
Exactly. It's a management tool. If you have 20 data scientists who all need the same permissions, you don't configure 20 individual users.
Right.
You create one data science group, attach the permissions to the group, and every user in it automatically inherits them.
That makes perfect sense. It's managing at scale. Now, the one that always feels a bit more abstract is a role. How is that different from a user?
This is a crucial concept, especially for security. A user has permanent credentials, like a password or a secret key. A role, on the other hand, is an identity with permissions that doesn't have its own credentials. It's designed to be temporarily assumed by a trusted entity.
Assumed? What does that mean in practice?
Imagine an EC2 instance, that virtual server, needs to read a file from S3. Instead of storing a permanent secret key on that server, which could be stolen, you grant the server a role. The server then assumes that role to get temporary, automatically rotated credentials just for that task. It's like giving it a visitor's pass instead of a permanent keycard, infinitely more secure.
The temporary nature is the key. So that leaves policies. What are they?
The policy is the rulebook itself. It's a document written in a format called JSON that explicitly says what is allowed or denied.
Right.
A policy might say, allow a user to view files in S3, but deny them from deleting files. You then attach these policies to your users, groups, and roles.
So the policy defines the power, and the user, group, or role is who receives that power.
Precisely. And to give you more flexibility, AWS provides 3 types of policies: AWS managed, customer managed, and inline.
Let me try to break that down with an analogy. Is an AWS managed policy like a preset combo meal at a restaurant? Something standard like read-only access?
That's a perfect analogy. And a customer managed policy is when you build your own meal a la carte because you have specific needs. You can then save that custom meal and give it to other people later.
And an inline policy?
That's a special one-time only request to the chef that's just for you, just for this one meal. It's a policy that's tied directly to a single user or role and can't be reused. You use them sparingly.
This framework seems to bridge the gap between being easy for beginners and powerful for experts.
It does, and it all comes back to a core security practice we touched on last time. When you log into the AWS website, the console, you can log in as the all-powerful root user or as an IAM user.
And we said you should always use an IAM user for your daily work, even if you're the administrator, to practice least privilege and, of course, enable multi-factor authentication on both.
Absolutely. You only use the root user for a very small number of tasks that require it, like changing your billing details or generating access keys for the command line interface.
Right, the CLI. You mentioned that's a way to control AWS with text commands.
Yep. It's how developers and system administrators automate their work. Instead of clicking in the console to launch a server, they can write a script to launch 1,000 servers. It's incredibly powerful, and it's all authenticated and authorized through IAM.
Wow, so whether you're clicking on a website or running a complex script, IAM is the universal gatekeeper, controlling who can do what.
It is the central nervous system for security in AWS. Understanding how users, groups, roles, and policies work together is essential, not just for passing an exam, but for building anything secure and scalable in the cloud.
Now, here's a question we'd like you to think about. If you were to create an IAM policy for your own digital life, access to your photos, your documents, your social media, what would be the first rule in your deny list?
Welcome back to Cloud Concepts on the Run. I'm Tim.
And I'm Andy. So, Tim, we've established that an EC2 instance is our own private server in the cloud.
Right.
But before we get deeper, I think we're overdue for a little acronym recap.
Yeah?
It feels like we're speaking in code sometimes.
An excellent point. It's so easy to get lost in the alphabet soup. Let's do a rapid fire round. First, AWS.
Amazon Web Services. That's the entire universe we're operating in.
Perfect. Next up, EC2, our topic for today.
Elastic Compute Cloud. You know, they could have just called it ECC, but I have to admit, EC2 sounds a bit more hip.
It really does. It has a certain ring to it. How about S3?
Excited. Simple storage service, the 3 S's.
Yeah.
Which is a great mental hook because you've mentioned that standard S3 objects are stored in at least 3 locations to achieve that incredible durability.
Exactly right. That's how they promise 11/9 of durability. And last one, AZ.
Availability zone. That's a data center or maybe even a group of data centers.
Yep.
All located within a single geographic region.
You've got it. And for our listeners studying, the relationship between regions and availability zones will absolutely be on the Cloud Practitioner and Solutions Architect exams.
Okay, alphabet soup cleared up. Shifting gears. Let's get back to the main course. EC2. Where do we start?
We start with the menu. EC2 instances come in different types and sizes.
Okay.
You don't need to memorize all of them, but the key concept is that some instances are optimized for certain jobs, some for storage, some for memory, and some, they have powerful GPUs built in for heavy-duty artificial intelligence work.
So you choose the right flavor for your task, and each flavor comes in different sizes?
Precisely. You can get a small instance with just one virtual CPU and maybe 1 gigabyte of RAM.
Wow.
Or you can scale all the way up to a beast of an instance with 96 virtual CPUs and almost a terabyte of memory.
I'm almost afraid to ask about the price difference there.
It's as wide as you'd imagine. You pay by the hour or sometimes even by the minute.
Right.
A small instance can cost less than a penny an hour to run, while that huge beast might be $10 an hour or more.
But that's the whole magic of the cloud, isn't it?
It is.
If I need a supercomputer for 3 hours to run a complex simulation, I can rent it and then just give it back. I only pay for what I use.
That is the absolute core of cloud economics. A fantastic real-world example is a tax services company.
Okay.
In January, they're processing a massive number of year-end reports.
Right.
So they can spin up hundreds of powerful servers to handle that load.
Right.
But come May, after tax day,
They can shut them all down and not pay a single penny for those resources until they need them again next year.
exactly. We'll talk more about how that can happen automatically with something called auto-scaling in a future episode.
Okay, so now I have this powerful server running. How do I control who can talk to it?
Right.
How do I put the locks on the doors?
A crucial question. Your first layer of defense is the VPC, the Virtual Private Cloud.
Okay.
The best way to think about it is it's your own logically isolated private plot of land within the vast AWS universe.
My own private fenced-in neighborhood. So what are the security guards for this neighborhood?
You get two main types of firewalls. Let's start at the house level. Attached to each EC2 instance, you have what's called a security group. This is like the bouncer at the front door of your house.
Okay.
It inspects traffic trying to get in and out of that specific instance.
Got it. Bouncer at the house door. What's the other one?
The other is an NACL, or Network Access Control List.
A NACL.
If the security group is the bouncer at the house, the NACL is the main gate and fence around your entire property.
That's a great analogy. So for the exams, what's the one thing we absolutely have to remember about the difference between them?
It's one word: state. Security groups are stateful.
Stateful.
NACLs are stateless.
Let's break that down. What does stateful mean in this context?
Stateful means the bouncer at the door, the security group, has a good memory.
Right.
If your instance sends a request out to the internet, the security group remembers that connection.
Okay.
It tracks the state of the conversation.
Okay, that makes sense. So what about the stateless NACL?
The stateless NACL has no memory. It's like having two separate bouncers who don't talk to each other, one at the entrance gate and one at the exit gate.
Oh.
You must explicitly give both of them a list of rules. Just because you allow traffic in doesn't mean the reply is automatically allowed out.
Ah.
You must write a rule for that too.
All right, that was a fantastic deep dive. I think this is a natural breakpoint for today's run.
I totally agree. And it's the perfect moment to transition from theory to practice.
Yes.
We really, really encourage everyone to take advantage of the AWS free tier.
There is simply no substitute for that hands-on keyboard time. Spin up an EC2 instance, break it, and then shut it down. Do it again.
It's almost like Grand Theft Auto for the cloud. You can crash your EC2 instance all you want, abandon it, and then spin up a fresh one just minutes later.
It is, but with one very important difference from a video game.
Right.
You have to be careful. It is possible to rack up a big, and I mean a very real bill by provisioning enterprise-level resources and forgetting about them.
Oh, Absolutely. In fact, our human producer told us a story about this.
In his early days of learning, he was trying to fine-tune his first large language model.
And he spun up a powerful and very expensive GPU-optimized instance to do it.
And he got distracted. He forgot to turn it off. In just a single day, he racked up an $800 bill.
Wow. Oof.
It's a painful but powerful lesson.
Yeah.
And that's why in a future episode, we're going to dedicate time to showing you how to set up billing alarms. It's an essential safety net.
It is. And, we're AI and technically way smarter than our human producer. But he's the one with the real-world stories of expensive mistakes. He reads every comment and strives to produce good quality content to help all you curious minds on the run.
He really does. So please, if you're enjoying the show, take a second to like, comment, or subscribe.
Please do.
And whether you are tuning in while running, driving, working, or cooking, we hope you do it safely. Thanks for being with us.
We'll see you on the next one. Now, here's a question we'd like you to think about. What's a small experiment you've done in your own life, in the kitchen, in the garage, or on a computer that taught you a surprisingly big or maybe even expensive lesson?